All right. So thank you, everyone, for joining this section. This is college algebra, and today we would be discussing section 2.7, which talks about index. It talks about index functions. So first of all, let's look at the definition of an inverse function. So first is definition of an inverse function. All right. So we say let f and g be two functions such that f of g of x is equal to x and g of f of x is equal to x for every x in the domain of f. All right, so if this condition holds, then g can be said to be the inverse of f, or f can be said to be the inverse of the function g. If the composition of them leads to an identity function, then the two functions, one is the inverse of the other. So we can say the function g is the inverse, of the function f, and is denoted f inverse. Thus, f of f inverse is equal to x, and f inverse of f of x is also equal to x. And the domain of f is equal to the range of the inverse function f inverse and vice versa, meaning the domain of f becomes the range of the inverse function, and the range of the inverse function becomes the domain of f. So if two functions, one is the inverse of the other, the domain of the inverse function becomes the range of the function, and the range of the function becomes the domain of the inverse function. All right, so let's look at an example. So this is example 1. Example 1, and it says, show that each function is the inverse of the other. So each function is the inverse of the other. We have f of x is equal to 4x 7 and g of x is equal to x plus 7 divided by 4. All right, so to find out whether f is the inverse of g of x or g of x is the inverse of f, we have to find the composition of f of g of x and also the composition of g of f of x. And in each of these cases, we have to the result would have to be an identity function x, and that will conclude that one function is the inverse of the other. So first of all, let's find the inverse. Let's find the inverse. Let's find the composition of f of g of x. So f of g of x is equal to f of g of x is x plus 7 divided by 4. And this equals to 4 times x plus 7 divided by 4 minus 7. And this equals to x, this 4 divides this 4, so we have x plus 7 minus 7, which equals to x. And again, let's find g of f of x. G of f of x is equal to g of f is 4x minus 7. So this is 4x minus 7 plus 7 divided by 4. And so this equals to 4x divided by 4, which gives us x. All right, so since f of g of x is equal to g of f of x, and both are equal to x, this verifies that f and g are inverse functions. All right, so that is how we find an inverse function. Let's look at another example, which is example 1b. And 1b says find f of g of x f of g of x and g of f of x and and determine whether a pair whether pair whether the pair of functions f and g are inverses. of each other. Okay, so f of x is equal to cube root of x minus 3 and g of x is equal to the x cube plus 3. So to find whether they are inverse functions, we have to find f of g of x, and it should give us an identity function x. We should also find g of f of x, which should also give us an identity function x. Then we can conclude that both f and g are inverses of each other. So f of g of x is equal to f of x cubed. G of x is x cubed plus 3, and this equals to the cube root of x squared plus 3 minus 3, and this equals to the cube root of x cubed, and cube roots is the same as x power 1/3. So this is the same as x power 1/3, where this 3 cancels this 3, so we get an x here. Okay, so let's find g of f of x is equal to g of f of x is cube root of x minus 3, and this equals to the cube root of x minus 3 all cube all power 3 plus 3, and this equals to x minus 3 power 1/3 times power 3 again. So this 3 cancels out this 3. So we have x minus 3 plus 3, which gives us x. So since f g of x is equal to g f of x, and they are both equal to x, f and g are inverses of each other. All right, so let's now look at how to find the inverse of a function. Well, before we move on to find the inverse of a function, all right, let's move on to proceed to find the inverse of a function. All right. Uh, so the steps to finding the inverse of a function are: one, we have to replace f of x with y. Have to replace f of x with y in the equation. Equation 4. Equation for f of x. And 2, We have to interchange x and y. So you have to interchange x and y. And 3. Then 3, we have to solve for y. If this equation does not define y as a function of x, then the function does not have an inverse. If this equation does not define y as a function of x, the function f does not have the function f does not have an inverse. Does not have an inverse function. And this procedure ends. On the other hand, if this equation defines y as a function of x, equation does this equation does define y as a function of x, the function f as an inverse function. And if this function, the fourth step, if f has an inverse function, if f has an inverse function, then we replace this y in step 3 by f inverse of x. And finally, we can also verify our results by showing that f of f inverse of f is equal to x, and f inverse of f of x is also equal to x. All right, so let's look at an example. Let's look at an example here to kind of walk through some of the steps that we have just described. So this is our first example on finding inverses. So this is example 2a. Let's call this example 2a. And it says find the inverse of the function. Find the inverse of a function, and find the inverse of a function f of x is equal to 2x plus 7. All right, so the first step is we replace f of x with y. So y is equal to 2x plus 7. The next thing is we interchange x and y. So x is equal to 2y plus 7. And the next is we try to solve for y. So in solving for y, we can subtract 7 on both sides. So we have x minus 7 is equal to 2y. And now we can divide both sides by 2. So we have y is equal to x minus 7 divided by 2. Y is equal to x minus 7 divided by 2. Now we can replace y with f inverse of x. So f inverse of x is equal to x minus 7 divided by 2. All right. So let's look at another example, example 2b. And it says the function f of x is equal to x plus 8. X plus 8 power 3 is 1 to 1. Is 1 to 1. A, find find the equation for f inverse of x. F inverse of x, which is the inverse function. And B, verify that the equation is correct. By showing f of f inverse of x is equal to x, and f inverse of f of x is equal to x. Okay. Um, so the function we are given is f of x is equal to x plus 8 all to the power 3. So the first thing is we replace f of x with y. So we write y is equal to x plus 8 all power 3. And next we replace, we switch the place for y and x. So x is equal to y plus 8 power 3. All right, so now to find y, we can take cube roots on both sides. So that will be, we raise both sides to power 1/3. So x power 1/3 is equal to y plus 8 power 3 all to the 1/3 power. So x power 1/3 is equal to y plus 8. So this 3 divides this 3. So x power 1/3 is equal to y plus 8, which implies y, if we subtract 8 on both sides, we have y is equal to x to the 1/3 power minus 8. And this becomes the inverse of f. So f inverse of x is equal to x to the 1/3 power minus 8. Um, and the b part, let's verify that this inverse function, um, this inverse function, f inverse of x, is correct by verifying um, f of f inverse of x, which equals to f of f inverse of x is x cubed, x power 1/3 minus 8, and this is equal to x power 1/3 minus 8 plus 8 all to the third power. And so this equals to x to the third power, x to the power 1/3 times power 3, and this equals to x. And also f inverse of f inverse of f of x is equal to the f inverse of um, x plus 8 all to the power 3. And so this equals to x plus 8 to the power 3 times 1/3 minus 8. And this is equal to x plus 8 this power 1, 3. We divide this power 3, so we have x plus 8 minus 8, which equals to 8, which equals to x. All right, so we see that f of f inverse of x is equal to x, and also f inverse of f of x is also equal to x. So this verifies that f inverse of x is the inverse of the function f. All right, so let's look at the horizontal line test for inverse functions. Let's look at how we test for inverse functions using the horizontal line test. Okay, so um, All right, so a function f has an inverse, that is f inverse if there is no horizontal line that intersects the graph of the function f at more than 1 point. So let me write that down. So a function f has an inverse. The function f has an inverse that is a function f that is a function f inverse. It's a function f inverse if there is no horizontal line. If there is no horizontal line that intersects the graph of the function f at more than 1 point. All right, so let's use an example to explain this. So this will be our example 3. And this is which of the following graphs represents functions that have inverse functions. So for a function to have an inverse, the function must be 1-to-1. And how we test that a function is 1-to-1 is by using the horizontal line test. And it basically means if we draw a horizontal line through a function, the horizontal line must not intersect with the graph of the function in more than one place. So it means if a function is 1-to-1, it means for every single value in the domain of the function, it maps onto a single value in the range of the function. So if a function is 1-to-1, so if we have the domain, so we have some elements in the domain x, y, z. Each element in the domain maps on to exactly one element in the range. So if this is the case, then we say the function is 1-to-1. All right, so let's look at our example. So these are the functions. So we have two functions. Our goal is to use the horizontal line test to determine whether they are 1-to-1. So we have this function, which looks like the absolute value function. And so this is our y-axis. This is our x-axis. We have another function b, which is just, which is giving us all right. So to determine whether these two functions are 1-to-1, all is to use the horizontal line test. So if we draw a horizontal line through this first function, we see that it intersects with a function at more than 1 point. So the function is not one-to-one. So this function is not one-to-one. The function is not one-to-one. It's not one-to-one, which also means that it doesn't have an inverse. The inverse doesn't exist. And if we look at the second function, if we draw a horizontal line through it, we see that it intersects with it only once. So that means this function has an inverse. And it means this function is one-to-one and has an inverse, or I should say. All right, so that's how we test, or if we test how if a function is one-to-one. Next, let's look at if we have a graph of f, how we can also graph the inverse of f. If we are given the graph of f, how do we graph the inverse of f? Basically, for a graph of f, if you want to graph the inverse of f, then the domain of f becomes the range of the f inverse, and the range becomes the domain of f inverse. So we basically switch the domain and the range around to be able to graph the inverse of a function. All right, so let's look at graphs. Graphs of f and f inverse. So the graph of f inverse is a reflection of the graph reflection of the graph of it's a reflection of the graph of the graph of f inverse is a reflection of the graph of f about the line y is equal to x. All right, so let's use an example to illustrate this. So basically, a reflection of the line y is equal to x. So the y values become the x values, and the x values becomes the y value. So let's look at this example. So this will be our fourth example. And this is the graph of the graph of a function consists of graph of a function consists of two line segments. So of two line segments, one segment from negative to negative to -1 to 0, and the second segment from -1 0 to 1 2. And this is graph F, and use the graph. Use a graph to draw the graph of its inverse. All right, so f, the function, the coordinates for the function f that we are given are -2 and 2, -1, 0, and 1, 2. And the other that we are given are the f inverse, which is, so the f inverse will be a reflection about the line y is equal to x. So the y values becomes the x values, and the x values become the y values. So for this first pair of points, it wouldn't change since they are both -2 and -2. So still f inverse will be -2, -2. For this second pair, -1 becomes 0, and 0 becomes -1. And for the third pair of points, 1 becomes 2, and 2 becomes 1. All right, so this will be, so this basically means the domain becomes the range. Domain of F becomes the range of F inverse, and vice versa. So the first pair of points are the domain. So the domain are first pair of points, and so the domains becomes the range of the F inverse function, and the range, which are the second pair of points, becomes the domain of F, of the F inverse function. All right, so let's try to graph the function. Then we'll graph its inverse function too. So let's do that on the next page. One, two, three, four. All right, so for the original function, we have the pair of points, -2 and 2. So that is about this point here. We have -1 and 0, which is about this point here. And we have 1 and 2, which is also about this point. So for the original function f looks like this. So this is our f function f. The inverse, we have -2 and 2 again. 0, 0 and -1 is this point. And we have 2 and 1, which is also this point. So the inverse function becomes a line through these points. So this becomes the inverse function. So this is f, and this is f inverse. So that is how we graph inverse functions. All right. So let's look at one more example. Let's look at one more example on finding whether two functions, one is the inverse of the other. So similar to the example 1A and 1B that we looked at. So we'll call this example 1C. So the function function f of x is equal to 3x plus 5. Divided by x minus this 1 to 1. Is find an equation for f inverse. For f inverse of x, inverse function. And B is verify that your equation is correct. Equation is correct by showing that f of f inverse of x is equal to x, and the f inverse of x is equal to x. All right, so to find the inverse of f of x, we replace f of x with y. So in A, y is equal to 3x plus 5 divided by x minus 6. And next we switch, we interchange x with y. So x is equal to 3y plus 5 divided by y minus 6. And next we try to solve for y. So to do that, let's multiply both sides by y minus 6. All right, so this y minus 6 divides this y minus 6. So x times y is xy minus x times 6 is 6x, and this is 3y plus 5. All right, so we are solving for y, so we need to group the variables that involve y on one side and the others also on the other side. So if we subtract 3 on both sides, we're going to have xy minus 3y is equal to 5 plus 6x. And so from here, we can factor out y on the left side. So we can factor out y on the left side. So we can have, if we factor out y, and factor out y on the left side. So if we factor y out of xy minus 3y, we're going to have y times x minus 3, and this equals to 5 plus 6x. And we can divide both sides by x minus 3 now. And so we have y is equal to 5 plus 6x divided by x minus 3. So this means the inverse of x is equal to 5 plus 6x divided by x minus 3. And we should know that x cannot be equal to 3. Otherwise, this function is undefined. If x is equal to 3, the function is undefined. All right, so we found the inverse now. So now let's try to verify that. Let's try to verify that. Let's try to verify in B that f inverse of x is equal to x. So let's try to verify that f inverse of x is equal to f inverse of x is 5 plus 6x divided by x minus 3. And so this equals to 3 times 5 plus 6x divided by x minus 3 plus 5 divided by 5 plus 6x minus 6. Okay, so and this equals to 3 times 5 plus 5 plus 6x. If we find the LCM of the numerator, the LCM of the numerator is x minus 3. So this becomes 3 plus 5 plus 6x plus 5 times the LCM, which is x minus 3, and all this divided by x minus 3. So this is just for the numerator, and the denominator becomes, we do the same to the denominator, so we have the LCM for the denominator is x minus 3, so we have 5 plus 6x minus 6 times the LCM, which is x minus 3, all divided by x minus 3. And this simplifies to, when this simplifies to, we can change this division in the middle here to multiplication by reversing the rational expression at the denominator. So this becomes 3 times 5 plus 6x plus 5 times x minus 3 divided by x minus 3 times x minus 3 divided by 5 plus 6x minus 6 times x minus 3. So x minus 3 divides x minus 3. So we have 3 times 5 plus 6x plus 5 times x minus 3, all divided by 5 plus 6x minus 6 times x minus 3. So we can expand the numerator and the denominator. So we have 3 times 5 is 15. 3 times 6x is 18x. Plus 3 times x is 5x. Minus 3 minus 5 times 3, which is 15. And this divided by 5 plus 6x. And negative 6 times x is negative 6x. Negative 6 times negative 3 is positive 18. So this becomes negative 15, positive 15. So this becomes 18x. This was 18x. 3 times 6x is 18x. So this becomes 18x plus 5x, which is 23x, divided by positive 6x, negative 6x. So 5 plus 18 is 23. So 23x divided by 23, which is equal to x. So this is for f inverse, f of f inverse. So the next, let's find f inverse of f of x. So f inverse of f of x. And this equals to f inverse of f of x is f of x is 3x plus 5 divided by x minus 6. So this equals to 5 plus 6 times 3x plus 5 divided by x minus 6. All divided by 3x plus 5 divided by x minus 6 minus 3. All right, so let's simplify the numerator and the denominator by multiplying through by the LCM. So we have 5 times x minus 6 plus 6 times 3x plus 5 divided by x minus 6, all divided by 3x plus 5 minus 3 times x minus 6 divided by x minus 6. So we can change the division sign to multiplication, and so that becomes 5x minus 6 plus 6 times 3x plus 5 divided by x minus 6 times 3x plus 5. Let me do it on the next page. Let me do it on the next page since the space here is too small for this. So let's do this on the next page. So this becomes 5 x minus 6 plus 6 times 3x plus 5 divided by x minus 6 times x minus 6 divided by 3x plus 5 minus 3 times x minus 6. Okay, so x minus 6 divides x minus 6. And so we have 5 times x, this is 5x. 5 times negative 6 is negative 30. And plus 6 times 3x is 18x. 6 times 5 is 30 divided by 3x plus 5. And minus 3 times x is minus 3x. Minus 3 times minus 6 is positive 18. So this becomes minus 30 plus 30 becomes 0. So we have 5x plus 18x, which is 23x, divided by minus 3x also from 3x minus 3x goes to 0. So we have 5 plus 8, which is 23. So this also becomes x. 23x divided by 23, which also becomes x. All right, so this brings us to the end of section 2.7, where we looked at rational functions, and so we shall continue in the next one.